Okay, 4.3, solving quadratic equations by completing the square. This is actually going to be a really easy and a really short unit. We kind of already talked about it right before the last unit test, that you can actually solve for what x value, like given a y value, what x value would make that true. You can actually answer those questions from vertex form. Remember, you cannot do that from standard form. So if you get a question like, say, what is 4x squared, if I find a pen that writes, I'll write it all in black. If you had something like 4x squared minus 2x plus 7, and you're trying to solve for when that is like a height of 10 or something like that. So in this question, you can't actually solve for x directly yet. So in this unit, these are our ones where you're solving for a particular y value. These are also, if you subtract 10 from this equation, then you're actually solving for 0. So this is our solving for the roots, or solving for the zeros, or the solutions to this equation. That's why it's quadratic equations in this unit. So 3 different methods. Method number 1 that you've already learned is you want to factor it, but you've seen not everything factors. Method number 2 is you can actually turn it into vertex form and solve it from there. So let's look how that works. I did this really briefly before the test, but we didn't actually cover it in detail. So in this case, if you're trying to solve for when x squared equals 36, now here's the first rule. You probably know that you can do the opposite of square to both sides, which is square root. So I can square root an x squared, and I can square root a 36, which is, of course, going to leave just x and going to leave just 6. Now, this actually is only one of our solutions. We lost a solution here. And the reason we lost a solution is there's a restriction on square rooting which we didn't account for. There's actually many different ways to account for this. This is actually a really, really important mathematical concept. And it only ever works this way whenever you're trying to square root a square. So if you have the square and you're trying to get rid of it, every time this happens, when you square root, you can only square root a positive number, which means that you're only going to get a positive answer, and that positive answer is only going to be one of your solutions. Lots of different ways to think about this. Some people actually say this is not true. Some people just think of it like a rule. The square root of x squared is not x. There's 2 different ways you can write it. One is that you have to take the plus and minus of the square root, and that's the way I prefer. The other way is that the answer is the absolute value of x. You only found the positive version of x. And I've seen that as well. I'll kind of write that over here. Some people actually say that. So the square root of x squared is equal to square root of 36. They say that's a perfectly legitimate mathematical step, but then they say from there, the square root of x squared is just a really, really unique property. It's only the absolute value of x is equal to 6. And solving for that question, then either x is equal to positive 6 or x is equal to negative 6. So I've seen people write it that way as a solution. I had a lot of my professors in university write it that way. But in high school, I see more people actually write it this way. When they want to take the square root of x squared, they actually say it's equal to plus or minus the square root of 36. They actually just throw the plus and minus on there. They remember that when you're taking the square root, usually there's actually 2 versions. So it ends up being plus and minus 6, which is both of our solutions. Which makes sense, because if I put negative 6 into the question, if you square it, remember all the negative 6 will be inside brackets. So negative 6 times negative 6 still makes positive 36. So there are 2 solutions. And another fun note is it only ever works this way. If I say the square root of x is equal to 4, this guy only has one solution. This guy you're going to square both sides, which means that x is equal to 16. And this actually is only one solution, because it could not be negative 16, because you're not allowed to square root a negative, and that would have to happen first. So there is only positive 16 as the solution to this. It's because of the restriction. In this case, we started with an x squared, so every possible number is allowed. In this case, we started with a root x, so you're only allowed positive numbers. So in this case, we actually added something which only works for half of our numbers. When you add a square root, it's good, but it's only good half the time. So we have to account for it. In this case, we're adding the squared, and squared's good all the time. So we haven't changed it at all. And this guy still is a perfect solution. Really weird rule, but you get used to it. You really get used to it in context. So usually when you're dealing with quadratic functions and when you're dealing with the quadratic formula, which we're going to get into the next section, you know there's always that plus and minus solution in there. In the Pythagorean theorem, you don't have this problem, even though you kind of should have this problem. It's because in Pythag, you're dealing with actual measurements of triangles, so you never really have a negative solution. And in fact, a lot of the time when you have a real-world question, so if you're trying to solve when the ball was at its highest, or when the ball hit the ground, or something like that, or what is the maximum area of the pen, the negative answer is actually going to be a fake answer. We're going to call it extraneous. It's not a real solution to the question that was presented to you. So usually there's a real solution, and sometimes there's a fake solution to every question. And almost always the negative ends up being the fake one. So in real world questions, it's not the worst thing to forget it, but if we're just talking mathematically, I do expect you to remember and find both solutions to this question. And sometimes in the real world there are two solutions as well, which is important. Okay, let's try and solve this guy. So this is now full-on vertex form. This guy was a little bit weird. He could be thought of as vertex form or standard form or even factored form. This is kind of all the forms. This is just a very simple equation. But this guy is definitely vertex form. Our vertex would be positive 4, negative 64. So let's see if we can solve for what value of x would make this 0. So what are our roots in this case? So first thing we do is add 64. Now we have to square root both sides. And I don't actually write the square root on both sides. I actually just move the squared. This is my usual way. Same thing as I did here. I didn't write plus 64 twice. I just moved the 64 to the other side. So same thing here. I'm going to move the squared to the other side and do squared root. So we don't need brackets anymore. And it's going to be square root of 64 plus and minus. There's actually two solutions now. And this is important to keep in exact form if you're my 20-1s. Is root of 64 a real number? Yes, it's 8. So it's actually plus and minus 8. And then we have to add 4. So it's plus and minus 8 plus 4. Now you could write it just like that, especially if there's a root. You would actually leave it in this kind of form. But since these are real numbers, usually what we do is we kind of branch. We separate that plus minus into two solutions. So either x is equal to positive 8 plus 4, which is 12, or negative 8 plus 4, which is negative 4. So two solutions, positive 12 and negative 4 in that case. Okay, example 2. Solve each quadratic equation by completing the square. Express your answer as exact roots if you're in my 20-1s. You can change it to decimals if you're in 20-2. So we need to complete the square. This is a simple one. So first thing, we need to get rid of the last number. So a squared plus 18a plus 32. We don't care about. 18, so let's find our c star. 18 over 2 squared, which is 9 squared, which is 81. So we add a minus our plus c star and kick out the negative 81. So everything inside the brackets becomes a plus 9, all squared. Outside the brackets, 32 minus 81 equals negative 49. Okay, now we have it in vertex form. Now we only have a single a value in this entire question, which means we should be able to actually solve for this a value. So first we add the 49. Then we square root. Plus or minus. Make sure you always remember it at that step. And then we subtract 9. Is root of 49 a number? It is 7. So this one isn't actually a problem. Maybe the next one will need exact roots. So this is a is equal to plus and minus 7 minus 9, which means we have two different solutions. A is equal to positive 7 take away 9, which is negative 2. And negative 7 take away 9, which is negative 16. Good. That's it for this one. So don't forget how to complete the square. We're still going to use it from time to time. Last, a couple more questions. Okay, complete the square. I think I'm going to do this one. Maybe this one I'll just show you the answer, and I'll do this one completely because this is harder. You should probably pause and try these on your own first. Make sure you remember how to complete the square. For this guy, you should get to the point where you say t minus 4 squared. Make sure I've got it correctly here. Minus 20 equals 0. And then you should solve for t is equal to root 20 plus 4, or t is equal to negative root 20 plus 4. So you should be able to get to those solutions. So the 20 is going to move across, then you're going to square root it and have the plus and the minus version. Some people write this as solution 1 and solution 2. It's a bit tricky whether it's and or. Actually, I would say it's and. Two solutions, both of these are true. If you're looking for the roots or you're looking for the solutions, it's T1 and T2. I don't mind just writing T though, but this is actually probably a little bit better. Okay, last guy. We need to throw away the 141. We need to common factor the 4. So we only have an s squared at the front. Now what is 48 divided by 4? That's 12. So that's what it should look like at the very beginning. This is a plus. So we tossed out our c value, and we common factored our a value out of just the first two terms, which means both of them shrank by a factor of 4. Okay, now we need to find our c star. That is 12 divided by 2 squared. So 6 squared is 36. So plus and minus 36. Now we need to get rid of that guy and common factor. No equals on this side. I almost did that. It's actually an equals 0 over here. So 4. After I complete the square, it's going to be s plus 6. Now the negative 36 on the outside is going to be negative 36 times 4 is 144. So negative 144 plus 141 is going to be negative 3. If I did that right. Yep. Good. If you need extra practice on completing the square, please ask me and I can walk over these ones with you. Now, solving for this, add 3. Not square root yet. We still have something on the other side. I call this the onion method for rearranging equations. So you have to peel the onion from the farthest to the outside and then to the inside last. So the 3 was the first thing to go. It's our outside layer. 4 is the next thing on the outside, so it goes next. Now we square root. Plus and minus, and then we subtract 6. Good. And then we write our answers. Oh, they simplified this a little bit. So you look to see if you can tidy up the square root at all. And the square root of a number, in case you forget, if you have, say, square root of a over b, it looks like it's going to be impossible to tidy up, but it actually simplifies down to just square root of a all over square root of b. So if either number can actually simplify, then you can simplify the whole thing a little bit at least. So you can't take the square root of 3, that's going to turn into a really ugly irrational number, but you can take the square root of 4. So we're going to actually break this down into S1, which is positive root 3 over 2 minus 6, and S2, which is negative root 3 over 2 minus 6. Now don't forget, this bun at the back here does not flip signs. Only the sign with the square root flips from positive to negative. It's always minus 6 at the back. And that should be our 2 solutions. Sorry, it's a little bit hard to see. I should try and write a little bit bigger. Good. Solving quadratic equations by completing the square. Determine the solution. Determine the roots to the nearest hundredth. Then use technology to verify your answer. So now we're going to be using decimals. That makes things a little bit nicer, and we need to check it using graphing calculator. So, complete the square. Gets a little bit boring, to be honest. Once you know what you're doing, it's this exact same thing every single time, except this time we're going to end up with fractions or decimals. So negative 3 divided by negative 2 is going to be 3 over 2 is 1.5. So plus 1.5x plus 7 we threw out. So that's how we start. We can turn it into a decimal because we're going to be rounding eventually. And that's not rounded at all yet. That's exactly our answer so far. So we're not worried about rounding too much. Now what is C star? 1.5 divided by 2 squared. That is going to be 0.5625. I'm going to keep all the decimals for now, just because if you round too early, sometimes it can make the answer wrong. So plus 0.5625, subtract 0.5625. Okay, we get rid of the negative version. So negative 2, half of this is 0.75 squared. Now I'm going to find what our last term is. So 0.5625 times 2. So it's negative times negative, so it should be positive. So positive 1.125 plus 7. And I get at the end plus 8.125. So a bit of hard numbers we're dealing with, but it's still the exact same method, so it shouldn't be too challenging. Okay, subtract, divide, square root. Negative and negative make a positive. So x plus 0.75 is equal to plus and minus the square root of 4.0625, which is plus and minus 2 to the nearest hundredth. Once you've taken the square root, you're pretty much done with all the rounding. So now we can just get to hundreds. And it's actually really close to the borderline, but it should be 0.12. Sorry, 2.02. 2.02. Subtract 0.75. So break it down. X1 is equal to 2.02 subtract 0.75, which is 1.27. And X2 is equal to negative 2.02 subtract 0.75, which is negative 2.77. Good. 2 solutions. That's it. So plug this in your graphing calculator and check to see if it works. You could actually go and calculate where the x-intercepts are in your calculator and see if they're the same number. Another way you could do it is you could switch to table mode. I think this is possible. You can usually switch to the table mode, and then I think you can enter in a value, say like what are you at 1.27, and maybe it'll tell you what the answer is. I think that's possible. I'm not sure. I know it's possible on Desmos. But either way, you should check your answer. At least check with common sense. See if these look like the right answers. Is the negative one pretty close to negative 3? Is the positive one just past positive 1? To see if this makes sense. Okay. Why is it sometimes more useful to complete the square than it is to solve the equation graphically or by factoring? Graphically. So graphically can be bad because it's not always perfectly accurate. So graphically, it sometimes will round the answers on you, and it's a little bit annoying. You have to have a graphing calculator. You have to have the tech available, or Desmos, or access to one of those 2 things to be able to solve it that way. And sometimes it's a little slow, but usually it's not too bad. It's probably not slower than completing the square, at least until you get really good at completing the square. So those are limitations with that. It will not give you exact answers. There might be some really advanced ones online that will give you exact answers graphically, but usually they don't. They have another way of solving these things. They don't actually do it algebraically. They have a faster way that they kind of pump out the answers for those things. So that's the limitations of that. So that's graph. For factoring, it's not always possible. Not always possible to factor to get to the solutions. If the solution is going to be an irrational number, if it's going to be like a square root where you shouldn't actually simplify it, then I don't think you can actually get to that by factoring. I think factoring can only find rational answers. In fact, yes, I believe that is always going to be the case, because there is nothing to square root when you have it in factored form. You can get to whole numbers and you can get to fractions easy enough, but you can't get to irrational numbers. So it can't find irrational solutions, i.e. Square root of anything. So if you still have something stuck in the square root where it doesn't turn into a whole number, then that's going to be an irrational number, and you will not be able to find those solutions through factoring. So factoring is a good algebraic way of finding solutions. It's faster than completing the square probably, but it doesn't always work. So it's a bit inconclusive. So going to vertex form and using this method is actually a pretty good solution. But most people never really do this one. This is kind of the one-off solution. But the reason we're practicing it first is because the exact method that we used here of turning the standard form into complete the square and then solving to complete the square, everything that we did in this is actually this guy right here. You could actually do it on the standard form equation with A, B, and C if you complete the square with those letters and then rearrange to solve for the solution with those letters. That's how you actually get the quadratic formula. You will actually prove this equation. So every single time it'll end up being this guy. So it's a good in-between step. This is actually just a simple version of what we did in that last lesson. And this is what we're going to be doing tomorrow. And this is very, very important. So we'll get to that again tomorrow. But practice this method first. Make sure you understand the steps. And this one's pretty quick. I think we'll actually try and do the next lesson today as well.